So what's the solution? I thought, oh,
अरे
no need of
भाई
DSU.
इजी था यार.
Everything was, sir. This was shit contest. This should have been solved in 1.5 hours, is what I'm saying. But okay, anyways. Now coming to A. So A, problem A, I'm given an N and I'm given a K, right? I can add any power of K. I can subtract rather any power of K from my N, right? So K raised to 0 or K raised to 1 or K raised to 2 and so on and so forth, right? So if my, and I want to make this N exactly equal to a 0. So one thing is I cannot add anything, right? So I'll have, if my N is, let's say, less than K, so that's an issue for me, right? Why? Because my K won't be able to subtract. If I, like, the minimum I can subtract is 1, but if I were to take a positive power of K, then I would go below 0. So my number of moves is N. And if I want to reduce my number of moves, I just subtract it with the biggest power of K. So that's what you have to do. Just keep on subtracting uh, with the biggest power of K until this condition is met. And when this condition is met, your answer is N. Just add N to your answer. So as simple as that. So you can see, if K is 1 or K is greater than N, then I can't do anything. I'll just have to subtract it with it and we'll continue. Then while K is greater than equal to N, basically this condition is not met. While, so we have a number and we find the biggest power of K that is less than or equal to N, right? So if I multiply by K and it becomes greater than N, then we break. And this biggest power will at most be till 30. Why? Because 2 raised to 30 is close to like 1e9, 1e9 or 10 raised to 9, whatever you want to call it. But yeah, so all twos, so it will be at most 30. I'm finding that power and I subtract my number and I increase my answer, and in the end we just add N to the answer and we see out the answer. Any doubts? Hello.
Simpler solution is
Hmm.
think of it as binary, like base k basically,
Yes.
and uska just add all the numbers base k.
Ha, correct.
So if you see
It's
my just
basically,
code देख ले,
ha.
मेरा code देख ले.
Ha 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 ha. Oh, 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 okay. Log n base k. Okay, fair enough. Okay. Yeah, understood. Log n base k. Yes. Yes, you can say that. Log n base k. Hmm. If k equals
You
1.
add n mod k and you divide by k. That's it.
Yes, yes, yes. Exactly. This is log n base k. Wavis. Nice, nice. Wow, wow. Beautiful. Huh. So what he's saying is basically, if I want an answer, like the number of the answer will basically be n, but in base k, right? But in base k. So if I want the number of digits in any base, that is basically log of n base k. So yeah, this is the number of digits in n if my base is k. So for plus 1, obviously. Sorry. Yeah. So plus 1. To B, okay. Uselessness. I see. Okay. We start off with B. So B, I'm given a bulb, right? And a few bulbs ahead are switched. So every one bulb is switched off. So I starting with 1, all the multiples of 1 are then flipped. Starting with 2, all the multiples of 2 are flipped. Then all the multiples of 3 are flipped, all the multiples of 4 are flipped, and so on and so forth. So basically, a number will be flipped the amount of times its factors occur, right? Its factor, let's say, occur 4 times, it will be flipped 4 times. If it has 5 factors, it will be flipped 5 times, right? So a bulb will be on if it is flipped an even number of uh, sorry, a bulb will be on if it is flipped an even number of times, right? So what numbers have even number of factors? Probably every number, right? So if you have like 20, you can write it as 2 into 10, right? 1 into 20, 4 into 5. So for every number you have a counter number, except in square numbers where the counter number is the same. So you have odd number of factors and that bulb will remain off. So for this thing, so up until n, there are, let's say, whatever perfect squares exist, that will be the number of bulbs that will be off. So n minus root n floored basically will these number of bulbs will be off, and this has to be equal to k. This becomes my equation, and if I want to satisfy this equation, I can binary search on my n, right? If n is too huge, completely fine, but it will be greater than k, right? So we go below and stuff. But if n is small, it will be less than k. So we can binary search on our answer. So the time complexity will be log square n. Why log square n? Because I'm searching for the square root and that requires log n complexity. You can search for square root by literally binary searching. How, I'll just show you in a minute. And this is basically the time complexity. So 30 into 60 rather than log square n per test case. So how are we supposed to find the root by binary searching? Let's say root exists between 1 and 1e9. So if I get to a number x and I want the root of n, right? So if x into x is greater than n, that means my root will be somewhere here. And if it is less than n, that means my root will be on the right. So that's basically it. That is how you can do binary search for the root. So this is basically that function of get square root. And yes, so here I'm binary searching and then I'm getting a square root. If half minus square root is less than k, so which means that answer is not possible yet. So left is equal to half plus 1, else we have right is equal to half. Like basic binary search stuff, that if an answer is possible,
And
right will
mine
go till there. Huh? Hello?
mine might TL even.
You're my TLE, why?
Yeah, I'm iterating. कि I'm adding the next terms.
Next terms
जैसे भी
meaning?
जितने भी roots है, if I'm at an x,
हाँ
जितने भी roots है अभी तक,
हाँ.
I add those number and then check for that. Iterating.
How did it
Yeah.
pass then? Because they will have taken care of the case where there are uh because 10 pretest, right?
It won't pass.
No, matlab, because see, there's 10 pretest, right?
Hmm.
So one pretest will be, and what is this constraint? 1e4, right? So one pretest will be 1e4 and all worst cases. They
Yeah,
make the
first is
pretests.
118, no?
Yeah, no, not 1e18. Oh, you are iterating, so yes, 1e an AC in the system testing. Because why would they do something and make weak pretests, right? So that you don't get any seed,
Yeah.
kind of.
But yeah, solution if they don't think about it, then probably.
Probably. I don't know. Huh. Now coming to C.
Also, I didn't Python because for addition it was overflowing.
Wow,
Multiplication.
magic!
Exactly.
हाँ
मेरा गेट स्क्वायर रूट फंक्शन अलग से क्यों लिखा
easier.
और इनबिल्ट क्यों यूज नहीं किया
Ah,
इनबिल्ट क्यों
Inbuilt,
यूज
so
नहीं
there are a lot of issues.
inbuilt
अच्छा इसलिए
might
रॉन्ग आ
be
रहा है क्या मेरा
squaring issues. हाँ,
Probably.
you
मतलब
might
अगर
use.
तेरे को विरम सुन एक
हाँ
एक्स मिल गया तेरे को जो सेटिस्फाई कर रहा है के लिए तो
हाँ.
यू नीड टू चेक ओनली फॉर एक्स एंड एक्स माइनस वन राइट
If
बाकी कोई
if I
एक्स
sorry
ये
what?
देगा ही नहीं तुम्हें
मतलब I get an x. So basically I get an
हाँ
n that is satisfying k.
हाँ
हाँ, so
तो ओनली
short.
एन माइनस वन इज अदर केस विच कैन सेटिस्फाई के
No,
it's
probably.
smaller than n plus 1 the like for
Yes,
k
yes,
equals to
yes,
6
yes. You can
n
say.
3
You
and
can
n
say. You
n
can
9
say. You can
हाँ
say. Yes, yes, yes. Probably. I don't know.
अच्छा तो
Uh,
रॉन्ग आंसर क्यों दे रहा है भाई कब
no,
से
why will that be? Wait, n minus 1 is the
देख
only other that can satisfy k. Wait. So I get. Nah.
n तेरा 9 और 8 होगा तो k 6 आएगा दोनों
Ha, but if n is
एवरी परफेक्ट
30
स्क्वायर का देखना
and 29,
तो 30 देगा आउटपुट अगर 20 ने राइट नहीं
30 is 25 and
29 is
29,
20
24. 5 squares, na?
हम्म,
Huh. Why will that work?
तो पीसीडी हो जाए फिर देख ले मेरे पास कोड
Okay.
नहीं मतलब 25 तेरा k है
Huh.
अगर n satisfy कर रहा है तो there is a chance n minus 1 satisfies if n minus 1 does not
See, if
satisfies you print n
25 is my no 20, yes, 25 is my k. So if my k is
30 तो
21,
satisfy मिल रहा है
so that is on if the number is a root. So if my k is 20,
हाँ
so I am
okay
removing that root also and I am subtracting 1. Meaning, so this is my n and I am
हाँ
going root n.
मतलब मैंने edge case तो देखा है ना सब वैसे
ना मतलब okay. N minus root n, right?
इनबिल्ट स्क्वायर रूट
So
कुछ का प्रॉब्लम होगा
if I am
लॉन्ग है इसलिए
subtracting 1 from here, I will also subtract 1 from here, meaning if you expand
Inbuilt square root type problem.
अंडरस्टूड
root n plus 1 minus 1.
स्क्वायर रूट का ही होगा ना
Very much possible.
अरे यार
Now coming to C. So C problem states that if A, I want to find a number A such that A or B minus A and C, these are in brackets, is exactly equal to D, right? So what we can do is we can just switch this over and make test cases, right? Now I have A or B has to be equal to D plus A and C, right? So let's just, what are the possible combinations that I can have for a certain bit in B, D, and C? So let's just assume we have 0, 0, and a 0, then 0, 0, and 1, 0, oh sorry, 0, 1, 0, 0, 1, 1, 0, no, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, and 1. So these are all the possible combinations I can have in B, C, and D, right? So these are all the possible combinations. So if this is a 0, 0, 0, what should this bit of my A be? It should be exactly 0, right? Now if I have So this cannot change and this cannot change. How can I get a bit over here? I can get a bit only by carry forward, right? So my I minus 1th bit has to be 1, right? So we can just write I minus 1th bit has to be 1. Now, if I have a 0 and a 1, so let's assume, uh, so I want, if I make it a 0, both will be 0. If I make it a 1, I'll have a 1, right? So this is my B, this is my C, and this is my, uh, sorry, this is my D, C, and a B, and I'm going to add here, right? So if I put a 0, 1, doesn't matter, right? So I'll just put a 1. Same thing over here. If I put a 0, so this will become a 0, and the previous one will want to have an I plus 1th bit will have to have a 1. But if I put a 1 compulsorily over here, I'll get a 1 as an answer. Now same thing over here. If I put 1 compulsorily over here, I get 1 as an answer. Or if it is 0, then the I plus 1th bit has to be. I can put a 1 here. Same thing over here. I have to put a 1 over here because the final answer has to be a 1, right? This has to be a 1. Now if I, let's say, come over here, then I can be very sure that this bit, if I want to make it a 0, then if this is a, let's say I put this thing as a 0, and here also it's a 0, my I minus 1th bit has to be 1, right? And let's say I put it a 1, 1. So 1 plus 1 is 1, 0. 1 plus 1 plus 1 is 1, 1. So again, my I minus 1th bit has to be 1. I have no other option, right? So my I minus 1th bit has to be 1. And over here, I need to have a 0 compulsorily. I can't have anything else. Why is it so that I can't have anything else? It's because uh, what do you say? I have yeah. If I have a 1 1, so if I put something like a 1 here, then 1 1, and the I minus 1th bit has to be 1. But if I put a 0 in here, then I can definitely make this a 0. Why? Because I'm like I'll have a 0 here, and 1 and plus 0 is always equal to 1. So that is why. So if you observe, these are literally binary numbers. These are numbers but in binary. So this is 1, 2, 3. Sorry, it's 0, 1, 2, 3, 4, 5, 6, and 7. So these are all my cases. This is 1 and 6, and this is the case for 7. So we can just make our number that way. Just go here, and we have, let's say, the ith bit in D set. Ith bit in, so if it is set or no, what it does n bit do? It returns if my nth bit is set or no in the number. So ith bit is set or no, basically. So if my bth bit is set, b ka ith bit is set, c's ith bit is set, and d's ith bit is set, we make the number, and based on the case we just implement it, and in the end we just run a small check that if this works, if a is -1, obviously we print out a, but if this does not work, then we print a -1, and if this works, then yes, we see out. Any
You
doubts?
want to see a simpler solve?
Without a doubt. Let's see. System testing. Genil. Oh, ऊपर.
Open.
I see. अरे इधर नहीं. अरे shit. A B C.
Hmm.
Okay. A is equal to B or D.
Bus. to C ना, तो वो तो zero रहने वाला है.
No similar bits to
B,
C. Why?
yeah,
Because
that
if
is
you
I
have
always wanted.
okay, this is अरे 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 okay, fair, makes sense. Makes sense, makes sense.
Yeah.
Easier implementation without a doubt.
समझा दे पहले तो.
हाँ
समझा दे लोग को.
हाँ.
Why B is all divided.
So what he's saying is that if if you just observe it here also, right? I want my bit to be why, yeah, so I want my bit to be this on A to get the value here, right? If I want B plus C, I'm doing this bit, and I want this B bit, so my C bit has to be equal to A, has to be equal to B XOR D, B or D, right? So, just observe, right? I have a 1 and I need a 1 at the end. So, if I XOR them, I'll have a 0. That is what I want. Same thing for a 1 0. If I have a 1 0 in the middle, I want a 1 at the end. But if let's say both are zeros or both are ones, then I want a 0 in the middle, right? So that's what the middle element is. And if I want it to be a 1 exactly, then my A, right? If I want it exactly to be a 1, then I my A can dictate the values in C, right? So if C has a 1 here and A also has a 1, it will dictate its value. But if C has a 0 and I want a 1 here, then it will become 0 and I won't get an answer. So it's just that. That is why it works. Really neat observation. Wow. It just makes it way easier. Nice. Okay.
I had seen this, but I was like, for some reason I thought the edge case here. So I went to I added A plus C wherever it was not possible.
Oh, okay.
But A plus C
Check all permutation.
that got overflow. And
Oh.
because of the overflow, I got an error.
Oh.
And then I just removed it.
Wow. Okay. So D, what is said is that I have points on a number line, right? And from here to here, I can get. So if so till let's say some k times, but the maximum distance is going to be 10, right? So till a maximum distance 1 till 10, how many ever times, k times, but it will always result in less than n. Like my A plus D into k will always result in less than equal to n. It is given in the constraints, right? My last number will always be this. Okay, so 1 through 10. So I can and I'm given this, and over here, and then this will also be connected. And so if it is 1 and 1, so the difference is 1, common difference, and the k that I'm doing is, let's say, up till 3, like 3 times we'll go ahead with this, 3 times. So this, and 1 to 3, and this, and this. So 1, 2, and 3 times that way. So these are many edges I have made. I need to find the number of connected components in this whole graph. So one thing, and the graph is not directed as I've drawn these arrows, it is undirected. Okay. So So now, if you take note of this graph, then you can see I need not connect all the edges. Why is that so? Why do I need not connect all the edges to check? Because my end goal is to check the number of connected components, right? So I'll go from here to here. I'll go jump from here to here and from here to here. So these are all the. So if I am at any of these nodes, right? If I happen to be at any of these nodes, while doing a DFS for checking a connected component, I'll just reach out to all the other nodes, right? So I just need to make the edge till the next value and check the number of connected components. So that's it. And how do I check the number of connected components in a graph? So let's say I have a graph of this sort, and here and here. So in a DFS, if let's say I have this as a graph, right? And this and this and this. If I start from anywhere in a DFS, I will cover all the nodes right in the graph that are connected. So I just start DFS from some random node. I like iterate through all the nodes. I start a DFS and I'm like, okay, so this is connected, this is connected, this is connected. Okay, so I've visited all these nodes. Now I come to this node. Oh, this is visited. I shouldn't go ahead. Then I come to this node. Oh, okay. So I visit. Oh, okay. All are visited now. Great. And then I come to this node and I'm like, oh, okay, this is visited. Then this node and this is visited. So the number of times you perform this DFS are the number of connected components in the graph, right? This is how you find the connected components, and this is how you make the adjacency list. And the adjacency list can be easily made. Why? Because we just have 10 of these Ds. So like from 1 through I can max jump to 11. So in these arrays, I just store at a particular distance what is the max k that I have to travel ahead. And I also store the next value, you could say. So the next value and what is the maximum distance, k distance I have to travel ahead. So that's what I'm doing in D. If you see, we are taking inputs. We made a vector of next and adk. At index 1, I'm storing the next value, and it will be max, because if I have a 1 here and then I do equal to k, so it will be overwritten to a 0. It has to be max k. Basically, what max step ahead using the difference d, I can go ahead. And now I'm making the adjacency list. So if I can make an edge from I through I plus 1, then we just push back both I and I plus 1 into it in our adjacency list, and then we just run a simple DFS to check the number of connected components. So that's how you solve D. And so
I overcomplicated the F out of the question.
undercomplicated it. I took directed graph first.
You see my code, you'll be like, what the hell is this?
Runtime error test 7. Okay.
My
Okay.
DSU is on M, not N also.
Make set some sort of find. Okay.
No, that is DSU only. Normal.
Understood. Make find and this you are doing a union. Nice. Okay.
Do you want to understand why code?
DS. Okay, this understandable. All 11 input probably. Oh, array LL3. Wow. Magic. Adjacency list.
Adjacency of M, okay, not M. Keep in mind.
Input ADK DS of D, comma A mod D. Okay. So at every so every distance and start point, let's say you are pushing start, end, and
And
index.
index.
Okay, make set of I. Okay, so parent and that is set. Fair. Oh, okay. For every M. Okay. So now
Now
you are
this part
iterating
merges LNRs within a
11
specific I comma j.
within a specific I comma J.
For example, it is like let's say 1
Okay.
and
Like
4 and 1 and 8.
so it will remove this and it will be 1 and 8.
Exactly.
Okay.
That
Okay.
entire part just merges it and it makes union set also both things.
Okay. So now 1 through 8 is a connected component, kind of,
Yes.
with the difference D.
1 through 8 is not a connected component.
With the difference D.
No. 1 comma 4 and 1 comma 8 is a connected component.
Oh, okay. Oh,
Like I am
that.
connecting the LNRs.
Oh,
Yeah,
okay, okay,
A,
okay,
D, and
okay. Ha, ha,
A
ha.
and D.
So, basic, understood. Oh, okay. Now binary searching on some value.
Now for every value in n, 1 till n,
Ah,
I'm finding the closest range for every modular. If there exists,
okay. Ah,
if there
man.
exists, I push back into the index ka array, and those indexes ka array I'm merging.
Okay. Okay.
Too much complication,
And then
but it
finding
works.
components probably. Wow. Magic. DSU. Genil favorite data structure.
Yes.
Wow.
DSU better code is of Q, sir. Very crazy.
Oh, yeah. Gorish also DSU. Wow. Oh,
Brilliant.
class. सीखो कुछ.
I had made. I couldn't find my thing.
Not class. Clean. Space.
This is the
Space.
template only.
Cleanliness.
Exactly.
Please
This is a very
learn.
clean code.
Learn. ARR. DSU. And iterations ARR of IJ. While iterations are okay, so he's just going through the iterations. Hmm. Oh, okay. DSU, you dot union set position I and J. ARR of position of ARR position of J is equal to 0. Wow. Plus equals J iterations is equal to max. DSU time complexity is less. DSU time complexity is less. Iterations is equal to max of exactly. Till how many points do you go ahead and then position you change, and why did it do this? Oh, okay, in the future it doesn't affect it. Fair enough. So DSU code is better. Yes, it is better. No need to make ADJ list. Fair enough.
Yes.
It's just better. Ah.
I just
E
realized how it will work. Very
E
easy.
basically you make
Stupid thing.
positive. It's you need pause. What do you say? Probability of occurring one odd times and probability of one occurring even times, right? So dp of I of, let's say, the certain bit of 0 denotes probability of occurring even times, and O 1 denotes probability of that bit occurring odd times. And how do you know if a bit is occurring even times or odd times? The transition will be dp of uh, so basically dp of uh, I minus 1. So it is occurring even times, right? And this is for even times, because this is a let's call it even. So let's call it even dp of I minus 1, that bit occurring odd times. So basically 1 minus that value, whatever, let's say k, multiplied by the probability, and same thing over here, multiplied by 1e4 minus the probability value. And this is how you get a dp. And yes, and this is how you can then this will be
You
added.
either do XOR or you
Here is
don't
a
do XOR.
k.
No?
Huh?
Either you XOR or you don't XOR.
Exactly.
But why
So
are you taking two deep? You don't need three states. You need only two states.
so this dp, nahi na, for every bit I'm checking, and if it
For
is
every
even
bit, we
or odd.
don't do, no. Just do n comma XORs ka DP array. Bit,
n
don't worry about bits.
n cross zors, you are saying.
Yeah, that
Okay.
is way better.
No, but how do I make a transition from that?
Array, it's just that you take XOR or you don't take XOR, no.
Huh. So
So
n.
you either you XOR it with the
Oh,
existing
okay. N cross
XOR
zor.
or you
Okay,
don't
okay.
XOR.
N cross. Won't it be too huge of an array though?
Array it will be huge. That's why you make XOR 1023 ka array every single iteration.
Oh, space optimization.
Yes,
K of
very good.
ICPC Camp 1. Wow.
Yes.
But this should also work. This has less time complexity, right? This is
Huh?
7 into 2 into
10
n.
bits, sir. 10 bits, sir.
Ah, sorry,
1023.
10, 10. Sorry, my bad. 10 into 2 into n.
ये 1 minus k क्या है?
1 minus k is opposite opposite parity. So if even, then odd. Say you.
अरे नहीं, but how will you force के by? Let's say I'm taking a XOR, ठीक है, for a
Uh,
bit, for a number.
uh,
It will affect the previous XORs also, no? Like the other bits as well, because I'm
ha
XORing
ha
it with
ha.
a
That
number.
is true. That is true. N's
I
or
thought of bits and
ha
bits.
ha
I
ha.
just refuted
N's
it.
or this is correct. Yes, N's or this is a better way.
You
And
have
then
to
we
do
get
ends only. You
for
can't do
even
systems.
and odd, right? And after getting for even and odd, you just iterate from 1 to 1023.
No. It's just literal brute force.
After I get.
I into even on कुछ नहीं
Sorry.
करने देगा.
In the end, तो I get frequency of these, na. So now I iterate over this thing, na, and then into n. Sorry,
Yes.
this thing squared multiplied by uh, whatever p I have into 10 raised to 4 raised to the 10 raised to 4 times the count, some count, mod, uh, and this whole mod inverse, uh, mod inverse m. I think this has to be it. Yes. It was this only. Yes. I didn't have time to implement.
If you want to see the code,
Nah,
Sambhav Jain ka code is very good.
I will write this thing because not
I don't know,
that.
just for the stream. Sambhav Jain ka code is very good.
Vavi. No, they will also write. The stream people. Oh, damn. This person see ish. Oh, queue submission hasn't come into enforcement yet. 85% done. Magic. super fast. Editorial out, nice. But people